Are live. Perfect. All right, we've done this before. We graphed polynomials. I think this was back in like October, November. We did this quite a bit. I remember the first time we saw it, it was tricky. Then we kind of reviewed it for the unit test. It got better. And third period, definitely saw that. Seen it the third time, it's going to be clockwork. Okay. There's 7 steps. There's 7 steps to do to get to your rough graph. The last step is doing a rough graph. And I want to also relieve some pressure with this because we're not finding, with our graph here, we are not finding the actual roots. That's outside the scope for today. We're not going to find these places here where we have the change in the turning point. So when we get down to the rough graph could look different for different people because we have a limited amount of information. I just want you to know that our rough graphs are really rough. All right, it's not perfect. If you guys stay in math and go to pre-calculus, you'll learn some of the things you need to complete it. But I think actually the best way to do this is to do each step as we work out this example problem. So go ahead and just write this example problem up here. We'll do step 1, just put step 1 there. And I'll talk about each step as I am running through this example problem here. So let's move it over. And there it is. All right, so we're just going to look at this graph right here. Again, it's very step. Good? All right. You get some bad candy? Half eaten? All right, we have this graph, this function right here. Remember g of x, f of x, all of that. Which one do you need to see? You can still see? Okay. So we have this graph right here. Remember, this is just function notation. G of x could be f of x, h of x, m of x. Doesn't matter. This is really just our y value here. Okay. So to start, first step is, and I'll put this here. I want you to go and star numbers 1 and 2. Go and star number 1 and 2. However you want to make your stars. It's really important. 1 and 2, once we have the information from 1 and 2, that's all we need. We can do all the other steps just from that information. So the key is to get the numbers 1 and 2 totally right, and it's not hard. Each step isn't hard. So looking here, finding our n value. Our n value is our first step. We're going to figure it out by looking at the highest exponent in the function. What is our highest exponent? 3. Exponent, 3. Highest exponent, n is equal to 3. Is 3 an odd or an even number? Odd. You see? We just got number 1 right. That's going to help us. And somebody help me out. Name the coefficients. What are the coefficients in my function here? Just name them off. What are some numbers that are coefficients? 4. What else? Negative 7? 8 is a constant. So what's the difference? What's the difference between 8? Why did I say 8 isn't a coefficient? These are coefficients. There's no variable connected to 8. A variable tells me, or the number in front of a variable is my coefficient. So negative 7 and 4 are my coefficients. So let's look here. What is our leading coefficient? Connor, what's my leading coefficient up here?
The leading coefficient is
4. 4. Perfect. A is 4. Positive or negative? Positive. Got it? Okay. So we have 1 and 2 done. All the rest comes from 1 and 2. All the other steps come from 1 and 2. So let's look at some in behavior. You guys also remember this? Remember this one? Where it was x approaches positive infinity, what happens to f of x? Remember how much you guys hated that?
Yes.
So this is not in the scope of the unit, or for the midterm. This is not in the scope. I'm going to make you make. You are going to create a rough graph. And that notation isn't specific to that goal. So I'm going to leave that out for our training for this. Okay. In behavior. Kind of move. I didn't think so. I just want to ask. In behavior is talking about what happens on the outsides. As you go each way in the graph, what happens? Is it going up? Is it going down? Okay, we have different options, and our 1 and 2 steps tell us what's going to happen. In behavior, the highest exponent is even, or the highest exponent is odd. Which one was it? Odd. Okay. So I know I'm down here. The highest exponent is odd. Now, is my A positive or is my A negative? Positive. So I know that we end up with A is positive. It goes up and up. And you can even just add on to that. It's going down to the left. It's going up to the right. That's probably the hardest one to figure out. Now, the way I figured that out again was, I knew that I had to choose between the highest exponent being even or odd. I know it's odd. My A value is positive. Odd, positive. So I end up with the smirk up to the right like that. Turning points. Now, let's look at this. Turning points is when you're going, think of like a roller coaster. You're clicking up, clicking up, clicking up. Get to the top, what happens?
Go down.
You go down. Hopefully. You don't get stuck up there and have to walk those terrifying stairs all the way down. Now, how about this, though? What if I have this? How many turning points is that? Okay. Did we actually have a change in direction? On the roller coaster, did the roller coaster ever start to go up? Right? It's going down, negative slope, negative slope. Even if there's a zero slope, if it still goes negative, there is no change between a negative slope and a positive slope. There's no change between a positive and a negative. This has no turns. This is just declining, just going down the whole time. Okay, so the one thing here with turning points, it's easy to find, but you wanna make sure that you don't misinterpret some of the turning points. It has to go from going up to going down. Even if it goes up and then it goes sideways and then up, these aren't turns. A turn only counts if you change direction. So that's a lot of explanation for it. Bless you, bless you. Let's look. How do we find the turning points? I want you to go ahead and label it T, P. Turning points. It's in minus 1. So what does that end up being? 3 minus 1. We'll say 2 max. All right. I feel like if you zone out on one step, it might mess up everything. So try not to zone out right now, because if you find A, in and A, find numbers 1 and 2 here, you can do everything, but I don't want you to get confused. We only have this one example here. Number of real roots is equal to in. You can see that these are my x-intercepts. That's where it touches the x-axis. That's where it intercepts that. So I know that my number of real roots is equal to in, and that's equal to 3 max. Number 6, y-intercept. What do we do to find y-intercept? Plug in 0 for x, because think about it. If you have a graph right here, which we're going to graph soon here, if I'm here at x is equal to 10, right? 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Once x is 0, you're on your y-axis, so you know where that's crossing. So let's go ahead and plug in 0 for x. 0 for x, what's left? 8. You see? So this isn't where you have to like plug it in and do a lot of work and solve for an actual value. You're plugging in 0, so all the x's, all the terms with x's, gone. So we have 8. All right. All right, step 1 for graphing. I'm just going to give you some ideas here. These are graphing hints. Okay, graphing hints. Number 1, I'm going to go and graph my y-intercept. It's going to give me an idea of where the graph is just located, above or below. Connor?
Above, you count out 8 little steps.
Okay.
Or if you want to.
I could just put 8, right? It's okay. Yeah. Don't worry about tick marks when you're doing the rough graph. Next, I'd say let's go ahead and put the in behavior. In behavior. EB. So what do we figure out about the in behavior? It goes what? Down. And it goes up. Okay. You see how we're building it slowly, right? Now the next step is, when I look at 3, I want to look at probably the turning points first. Turning points. Turning points, how many do we have? 2 max. So this kind of makes sense, right? I'm thinking that probably it goes, it curves here, Maybe it curves up. I'm not sure. I have to think about the next step first. And the next step is looking at our roots. Our real roots. We have 3 max. 3 max. So, let's see. If it continues down, I know that it's probably going to cross down here. It looks like I could have it cross here and even cross here. That would be my 3 roots, right? Okay, watch. Now, I want you to kind of relieve some pressure on getting this perfect because you don't have enough information to get it totally perfect. Are you typing on a miniature keyboard?
Sorry.
That's fine. It's a tiny keyboard. Taking notes. I think it's fun. All right, so looking at this, you could end up with this. How about like that? You could have said, oh, I think it goes like this. That rough graph is acceptable too. Do you see how you couldn't get enough? You couldn't have more information. We don't. We are not going to find the roots. So this would be a rough graph that has 2 turning points. There's 3 roots. It's up and down the right place. So don't worry too much about your graph matching exactly. But I want you to, for the classwork, you're going to look at the boards. The 6 boards relate to 6 problems you have to work on. So you're going to try to match them. All right, what's the crux of this? What's the hardest part? Candy crux? Oh, wait, let's do first thumbs up, sideways, down for this. Oh, that's a lot of thumbs. In fact, that's all thumbs up. But somebody be creative. What's the candy crux for those at home? Stanley?
My problem is always remembering which direction goes up and which goes down.
Okay.
Sometimes it just messes with me a little bit.
So, the graph has to go up and down, and that confuses on how to make it fit. Okay, I think that's a good one. Connor, what's yours?
I get confused, and I think that the maximum has to be met, and so there's 2 max, but there's only 2 real roots.
Right.
That kind of confuses me.
So yeah, that's a good point to point out. It's 3 max.
Yeah.
It could have 1.
Yeah.
It's 2 max of turning points. It could have 1. So I think that's really good. That's something that confused a lot of folks for today's assignment because there's one of them that doesn't max out as much as we could. Yes, Michaela?
Sometimes I forget that there's a difference between a graphs when it's odd or even, which is a huge point. But
The odd or even will mess you up.
yeah, and I've done that.
Okay. So you're just going to look at what? The exponent? 3 is...
I mean, I just always assume it's just a problem. So, but it's not. I'm like, oh shoot.
Like going up to the right or down.
Yeah.
Okay. So don't forget about the smirks.
Oh yeah.
The
No,
smirks.
that's the thing. I always forget about the smirks. Always think smiley face.
Well, you verbalized it, so now you can't forget it.
Yeah.
All right. Anyone else? That's good. All right, what should we say? Anyone's birthday? Actually, it's Veronica Reyes Santos' birthday. Is that right?
Yeah.
It's her last name, right? Well, what should we say? Should we just say subscribe or something funner? We can yell bacon. We can try to sell used candy. Let's do bacon on 3. 1, 2, 3.
Bacon!
People in Brazil are like, what?